Hi, in this video I'm going to tell you how to run containers using AWS Fargate with Amazon ECS. AWS Fargate is a serverless technology that runs containers without having to manage servers. I will do all the actions using the AWS web interface. This is a diagram of what we will make. Users visit the domain published via load balancer. The load balancer balances traffic to targets. These targets represent front-end containers. Front-end makes requests to the backend server to fetch the information. Images for containers are stored in the ECR private repository. I am using VPC endpoints to connect to the repository. Let's take a look at the application that I will run. This application is pretty simple. I am using the Flask web server in both components, backend and frontend. Backend prints the string hello from backend service running on. Frontend fetches the backend string and adds information in the beginning. It is hostname. Front connects to the backend using the backend service URL environment variable. Docker files for the frontend and backend are almost the same. The main difference is the Python files. Let's run the Docker compose file to demonstrate how the application works. Frontend is running in one replica and backend is running in 3 replicas. You can see that the backend hostname is changing. I am going to use the Amazon Elastic Container Registry for storing images. You can see I've pushed my images to the ECR private repository. To do it yourself, just follow these instructions. I will allocate my containers in private subnets, so I need to pull images via private subnets. To implement it, there are VPC endpoints. VPC endpoint enables customers to privately connect to supported AWS services. I am going to use the last Fargate version, so we should create both Amazon ECR VPC endpoints and the Amazon S3 gateway endpoints. Before we will do it, let's take a look at my VPC resource map. Type in VPC and click on that. Go to VPCs. Select a VPC and click on the resource map. As you see, I have 2 public and 2 private subnets. Of course, private subnets don't have access to the internet. Then go to endpoints on the side. Click on the create endpoint. The name is optional. The service category is AWS services. Type ECR and select the first item containing ECR.api. This endpoint is used for calls to the Amazon ECR API, such as describe images or create repository. Choose your VPC. In the subnets section, I am choosing one private subnet. This VPC endpoint will be without high availability. I've created a security group that allows all inbound and outbound traffic for simplicity. In the next steps, I will use it everywhere. In the end, click on the Create Endpoint. Now we need to create an endpoint used for the Docker registry APIs. This endpoint is used to make push and pull requests. Repeat all the creation steps. Now select the item that contains ECR.dkr in the service list. Lastly, let's create an Amazon S3 gateway endpoint. This endpoint creates additional routes to S3 via private subnets. I will show it after creation. Type S3. Select the first item. Select the item with type gateway. Choose your VPC. In the end, select your route table for private subnets. Click on Create Endpoint. Go to the resource map of your VPC again. As you see, in the private route table appeared new route to S3. Let's go to ECS. Type ECS and click on that. Amazon ECS consists of 3 major things: clusters, task definitions, and tasks or services. A task definition is a blueprint for your application. In task definitions, you define the amount of resources, port mappings, and environment variables for your future tasks. A task is the smallest deployable unit in ECS. It runs 1 or more containers. The ECS task is like a pod in Kubernetes. You can run tasks in services. A service ensures that a specified number of tasks are running at all times in a cluster. Services are like deployments in Kubernetes. They control the desired number of tasks, and if one of them fails or stops, the Amazon ECS Service Scheduler launches another task to replace it. The cluster is a logical grouping of tasks or services. Let's start by creating a task definition for the front-end application. Click on Task Definitions, then Create New Task Definition. First, specify the name of your task. In my case, it will be my front-end task definition. Launch type remains. It is AWS Fargate. I am specifying the list values for CPU and memory. It is enough for demo purposes. I don't need a task role, so this field is empty. In the task execution field, pick Create New Role. This role is used to make AWS API requests on your behalf. For example, pulls a container image from an AWS ECR repository. Specify a name for the container and container image URI. I will take it from ECR. The container port remains the same. It's 80. I will not specify any location limits. As you remember, our front-end application needs an environment variable to connect to the backend. Let's add it. I will not configure login, so remove the checkmark Use Log Collection. Skip optional settings. Click on the Create button. Let's repeat task definition creation for the backend application. The name will be my backend task definition. Infrastructure requirements are the same as in the front-end task definition. Task execution role is created in the previous creation, so select it. Take image URI from ECR2. Containers will listen on port 8080. Uncheck Use Log Collection and click on Create. The next step is to create a cluster. Decide the name for your cluster. In my case, it will be my cluster. Keep the same name as your cluster's name for your default namespace. We will need a namespace when setting up communication between services. Make sure that AWS Fargate is selected in the infrastructure section. Skip optional settings and click on Create. Wait some time while your cluster is created. A cluster is running. Go into your cluster. We are ready to create services. Let's start by creating a backend service. In the environment section, select the launch type. Check that the launch type is Fargate and the platform version is the latest. Deployment configuration is service. Select the backend task definition. The revision is the latest. Note that you can't just change your task definition. When you want to make some changes to it, you need to create a new revision of your task definition. Assign a unique name for the service. The value for desired tasks is 1. I will use Service Connect to connect my tasks. The client-side only type is used when your service only needs to make outgoing requests to other services. The client and server type is used when your service needs to both send requests to other services and receive requests from them. For backend service, select Client and Server type. Service Connect uses the AWS Cloud Map namespace as a logical grouping of Amazon ECS tasks. Each Amazon ECS service can belong to only one namespace. In my case, the namespace is my cluster. We created it on the cluster creation step. Click on Add Port Mappings and Applications. Select Port alias, discovery name and port. The value of the backend service URL environment variable defined in the front-end task definition depends on the discovery name, so you should set the discovery name backend. The port is 8080. We defined it in the code of the backend application. Uncheck Use Log Collection. In the networking section, select your private subnets where tasks will be allocated. Then select the security groups. In my case, it is the group that allows all traffic. Turn off auto-assigning public IPs to the tasks. Skip other options and click on Create. A backend service is created. Go to the tasks. Everything works fine. The next step is to create a front-end service. Before doing it, let's create a load balancer for our front-end. Open another tab in your browser with AWS Management Console and go to EC2 Services. Click on Load Balancers on the side and then create Load Balancer. In my case, I will use Network Load Balancer or NLB. Define a name for your balancer. Scheme and load balancer IP address type remains. In the network mapping section, choose subnets where the load balancer will exist. In my case, all public subnets are in each availability zone. Select security groups. In the listeners and routing section, we need to define the target group where the traffic from the internet will be balanced. Let's create a target group. In basic configuration, choose IP address type. Then define a target group name. Other settings are correct. The protocol is TCP and the port is 80. The IP address type is IPv4. VPC is correct. Click on Next. In step 2, remove an entry. Check that port is 80. Click on Create Target Group. Go back to the creation of our load balancer. Update the list of target groups and select the created target group. The protocol and port are correct. Review the settings and click on Create Load Balancer. We are ready to create our task for the front-end application. To do it, go back to your cluster. Click on Create in the Services section again. The environment is the same as in the service for the backend. Select Front-end Task Definition. Revision is the latest too. Decide your service name. In my case, it will be Front-end Service. The desired task's value is 1. It's okay. Turn on Service Connect. For front-end service, I need to select client-side only because it only makes requests to backend service. Uncheck Use Log Collection. In the networking section, select the same settings as in the backend service. In the load balancing section, select Network Load Balancer type and your load balancer created earlier. Specify the existing listener and target group. In the end, click on Create. Wait some time. If the service is not in a running state, after about 2 or 3 minutes, recheck your configuration. The service is created and the front-end task is running. Let's look at targets in the target group. There is one target. It is a front-end container. Go to the load balancer, copy the domain name and open it in a new tab. The application doesn't work. There is a mistake somewhere. Let's solve this issue. Check the service connect endpoint in the backend service. Here it is. I made a mistake when defining the variable backend service URL. Let's fix it and redeploy the front-end task with a new revision. I will just delete the service and create it again with a new revision. All other settings are the same. The service is created and the front-end task is running. Open the load balancer page again. Everything is running as expected. Let's increase the number of replicas in backend and front-end service. Wait while tasks are created. Tasks are running. Go back to the load balancer page. Update your page several times. You can see the string is changing. Load balancing is working as expected. That's it. Don't forget to delete all created resources. All resources for deletion are attached in the description. I hope this video was helpful to you. Don't forget to hit the like button and subscribe to the channel. See you. Bye.